Alright, let's solve the Leetcode problem. So the Leetcode problem is the maximum number of K-divisible by K-divisible components. I don't know, have you guys feel like these days, everyday Leetcode to the problem is anything related to the number K-divisible by something. So yeah, let's bear with us and then let's go through it. So this is an undirected tree. That means this is not the binary tree. So the tree can be in any file. And then n nodes labeled from 0 to n minus 1 with given an integer of n. And then two-dimensional integer array edge of length n minus 1 where edge of I is from index of A to B. So indicate that there is an edge between the node A and B in the tree. So we also given a 0 index integer array, which is the values in here, and where values are I, the values is associated with the index of node. So every numbers in here is the index. We could find the values in the values array, and then yeah, we can need to find the maximum number of component in any value spread. So a value spread of a tree is obtained by removing any set of the edge, possibly empty, from the tree such that the resulting component all have values that are divisible by k. So where the value of a connected component is the sum of the value of its nodes. Let's go through their assignment one by one. So for the assignment 1 in here, so if I have to go through it, I need the assignment 2 also. Let's drop in here. So we are given a 5 edge in here, which will be the 1, 2, 3, 4, and 0. So this is a total 5 edge. And then, so 0 is connected with the 2, and then 1 is connected with the 2, and 1 is also connected with the 3, and 2 is connected with the 4. That is where the edge means in here. So every index in here, like index 1, which is the 8, index 0, which is a 1, index 2, which is a 1, the index 3, which is a 4, and index 4, which is a 4. So k is a 5. So we need to find the subcomponent, not the tree. They call it components. So the combination of all these components must be divisible by 6. So if we check the assignment here, we got like this split into the 1 and 3. So index 1 and index 3, which is 8 in here, and which is 4 in here. So the total combination of them will be 12, and which is divisible by 6, which is given by k in here. So there's a one case. So if we go to the another subcomponents, we are given like 0, which is a 1 in here, and then 2, which is a 1 in here, and then 4, which is a 4 in here. 4 plus 1 plus 1 will be 6, and that is divisible by k. Right, so that is the reason why we got the 2 components, and we are returning these 2 components in here. So if we solve the problem like this, I think that is a pretty straightforward depth search problem. So what I'm going to do first is I'm going to create something like adjacents for us. Let's call it adjacent in here. And then that will be the nested integer array. And repeating with the empty array initially, and then a count of n. And then let's call it, we return the -1 first. And then just want to print out how is the adjacent array look like in here. So we have something round here. Let me see what I do round. Integer repeating. Oh, there is a parameter called count in here. So that is technically the nested integer array, something like this. So initially that is empty at first, and then what we are going to do in here is we're going to check like each edge is interconnected. So how can we do it? So to do this, what I'm going to do is I will go through each edge one by one. Let's call like edges. And after that, we have a point, something like A to B, since they mentioned like A to B in here, edge of 0, and then let's call B, which is the edge of 1. And then I'm gonna interconnect each other within the array. Let's call A will be the append to the B, and the adjacent of B is appending the A. So why do we want to do like that? So the reason is quite simple. Let's call like components is 0 initially, and then we will return the components in here, and then I will print out the JSON for you guys. So if we check this, what I'm doing here is I'm gonna put the index 0, which is a 2, so that's why 2 is here. So next index 1, 2 is here, that's why 2 is here, and then vice versa. For the 2 index, I'm putting the 0 in here, and then for the 2 index, I'm putting the 1, 0, 1, 2, here is a 1, and the next is the index 1, I'm putting the 3, index 3, I'm putting the 1, so index 2, putting the 4, so index 4, putting the 2. So this is very crucial by way of creation of the adjacent array, which could be useful in our default search. So let's create the intervention. Let's call like default search, and then each node will be the integer, and then we will have a one parent in here, which will be also the integer. That's technically we're checking. Let's say we have 1 and 3 in here, so 1 is a parent of 3 for sure, and then we are returning the integer in here. So for this, we are going to take the sum of the values from node. So technically, every time we are going through the each node by checking the attribute value of the nodes, and then we're gonna keep it as a sum, and then we are iteration through from each child of that node. Let's say like adjacent of the node. For instance, if we are going for the something like let's start with the 0, since the 0 is 1, so here's a 1 node 1 come in. So like values of 1 is 8, and then adjacent of the node, so node is 1, so our adjacent of 1 node is like 2 and 3 in here, 2 and 3 in here. So what I'm going to do, I will check the one condition in here. Well, the child should not be not equal to the parent. So if it is equal, that means we are checking the same node again and again. So I am receiving the 2 and 3 in here. So what I'm going to do is I'm gonna sum of a child. So since we have like 2 and 3 of the child, and then we're gonna increment our sum in here with our default search of each node. Maybe we pass in the child and node. So child means like we are checking the each node in here. Let's consider that we are checking the 1. So we have 1 have a 2 childs in here, which is 2 and 3. So we are calling the default search again in here, which is a something like a nested version, and then we check in the 2 have a kids, which is a 4 and 0. It's 3 to have a kid, so that will stop in here, and then we're gonna update our sum values in here. After that, what I want to do is I'm gonna check like if sum is divisible by k, which is given in here, and that is our actual problem coming. So if divisible by k and our modulo begin to 0, I'm gonna update the components to the +1. So that way keep update. Like if we are able to find the one sum that is divisible by k, we just increment the components to the +1. So that will be our answer. And don't forget to call our default search starting from the 0 index by pressing the -1 as the initial parent value, since the -1 is not exist in our constraint. And yeah, the end value is always start from 1 to 330,000 if I'm not wrong. Yep, let's try to run it. Wait, I think I make something wrong here. I need to return the sum since we're returning this one values in here. And yes, I think the space complexity will be O of n and the time complexity will be O of n also, since we are just iteration through of the each edge one by one. Let's check the time complexity. Yes, time complexity is O of n, and then the space complexity is also O of n. Yep, that's all for it, and I'll see you in the next one. Bye.